Doc here on a review of Harmonics, Chapter G. And first, let's look at some animations. H1 stands for harmonic 1, H2, harmonic 2, harmonic 3, harmonic 4. The first harmonic, also called the fundamental. Crest, trough, crest, trough, crest, trough. A crest turns into a trough and vice versa. This is the most simple vibration for the string. The second harmonic has a crest and a trough taking turns, one here crest trough, and here the reverse taking place. You have two halves. Just think of this as a half of a wave, a crest trough, crest trough. This is half a wave. Here you have two halves, and the frequency is doubled. Here you have three halves, three humps, and the frequency is triple. And here you have four humps, a hump being either a crest or a trough, and the frequency is four times. Let's head over to our PDF file, Downloads, G, and let's look at this in more detail. We're going to find the case where we have four of these pictures that represent what you have seen as an animation. And here we want to master the physics by looking at it in three ways. One way is going to be from the master formula. Another way is going to be visual. And the third way is going to be a little tricky using mathematics. But remember, the three ways are equivalent. You really only need to know one way to get the answer. So let's find what the wavelengths are. For the first case, we'll use all three approaches. The first approach is, let's go with the master formula. The master formula says I take 2L, which is the distance from one wall to the other, the length of the string, 2L, and divide by the number that I'm looking at. This is the first case, second case, third case. The first case is 1. So 2L over 1 is 2L. We're finished. The wavelength is 2L from the master formula. Now let's do it another way. Another way is by visual analysis. Visual analysis says, look, if I want to look at this half a wave and I want to draw the other half, I would have to go over here to a distance of 2L to finish the drawing. So wavelength is 2L from visual artistic sort of analysis here. The third is mathematical analysis. We want to fit a half a wave in the distance L. So we translate that into mathanese. We fit a half a wave to L. Then, when you have an equation, you can do the same thing to either side of the equation. You don't change the equality. So if I multiply both sides by 2, then 2 times 1 over 2 is 1. The 2's cancel. And over here I have 2L, which is the answer. So you have three ways. Let's look at the next one in these three ways. The first way here is the master formula. I start with 2L and I divide by the case. What's the case here? Well, I have the second case. I have two humps, second case. So what's 2L divided by 2? Well, L. We're finished. The wavelength is L. What about by visual inspection? By visual inspection, I see I have a crest and a trough. I have one wavelength beautifully fitting in this distance L. I'm finished. The wavelength is L. What about the mathematical way? Well, I'm going to fit two halves to L. So two halves, I'm going to fit the two halves to this distance L. So two half waves, this is the mathanese now for those words, two half waves, fit it to L. Now once when I have this, I can do the mathematical manipulation here, 2 times a half, the 2's cancel, and I have my result. The wavelength is L. Going to the third case, analyze three ways. The first way, the master formula, you take 2L and divide by the case we're looking at. Well, this is the third case because I have three humps, 1, 2, 3. So what's 2L divided by 3? That's it, 2L divided by 3. We're finished. Visual inspection. Well, visual inspection, I have a crest and a trough, and that would be one wavelength. But hey, look, that's 1/3, 2/3, 3/3. That's 2/3 of the way across. The wavelength is 2/3 L. Third way, the fitting room analysis, the math way. here, more pure math way. So I have here a half wave, a half wave, a half wave. I want to fit 3 half waves to L in the fitting room. So there's my setup. I can do the same thing to both sides of the equation. I divide by 3. This 3 goes away on the left. I have L over 3. And then multiply by 2 to kill the 1 over 2, and I get 2/3 L the same way. Remember, you don't need this way. You already have 2 other ways of doing it, but it helps to see things in more ways than one. And in fact, this can help you with the quantitative analysis of the equation the math way, where you have the other 2 ways supporting you. In other words, you already know the answer, so you're confident. You don't have to be under pressure to do it this mathematical way. This fourth case here, by the general master formula, you take 2L and divide by 1, 2, 3, 4 humps by 4. 2L divided by 4. That's 2/4 L. That's 1/2. So the wavelength is 1/2 L. The visual way is to look for one wave. Here it is, a crest and a trough. And hey, look at that. That's in the middle. That's in the middle. I went 1/2 the way. I'm finished. Wavelength is L over 2. Now the fitting room way, we're going to fit 1, 2, 3, 4 half waves to L. So we translate those words to Mathanese. 4 half waves fitted to L. And notice that here 2 goes into 4, so I can replace this with 2 times the wavelength is L, and then divide both sides by 2 and get the wavelength is L over 2. I encourage you to write down these things. When you study physics and math, it's always important to use paper and pencil to write the stuff out, and you will master the material.